So it's week 24 maintenance for the Pure Maths 1 course. Quadratics question first. We've got a curve and a line, and when m equals 1, so i.e. when y equals x, the curve and the line intersect at point A and B, and we've got to find the coordinates of the midpoint AB. So first of all, we need to find A and B. So I'm going to make these two, the curve and the line equal to each other. And then I can bring everything across to one side. And you can hopefully see that I can factorize it like so. And so I get x is equal to 1 or 4. Now, if that's the case, I can chuck in my y values and I'll find out that y is also equal to 1 or 4, given that we've got m is 1 here, so y equals x. Now, the midpoint would be, so we're going to go 1 plus 4 over 2, comma 1 plus 4 over 2. So we should get the midpoint is at 5, 2, comma 5, 2. And there we go. Find the non-zero value for m for which the line is a tangent to the curve. And find the coordinates of the point where the tangent touches the curve. So what we're going to do is we're going to take this here again, except that this time x is not 1, it's mx. So when we take it across, we should get x squared minus 4x minus mx plus 4 equals 0. And we can factorize that, so we'll get plus x into negative 4 negative m plus 4 equals 0. Now, if it's a tangent to the curve, we know that the b squared minus 4ac should be equal to 0 for it to have one root. So in that case, I'm going to now apply that. So I'm going to go minus 4 minus m all squared. Sorry, that's b squared. Minus 4 times 1 times 4. Now this will give me 16 plus 8m plus m squared minus 16 equals 0. And so you're going to get m squared plus 8m equals 0. So you just factorize at this point and you get this. And so we get m is equal to 0 or negative 8. But since we're told that we're trying to find the non-zero value for m, we can ignore that one. So m equals negative 8. And then we've got to find the coordinates on the point of the curve where the tangent touches the curve. Okay, so when m equals 8, we've got x squared, and instead of minus 4x plus 4 equals negative 8x, and we just bring that across, and we'll get x squared plus 4x plus 4 equals 0. So I think we get x plus 2 all squared equals 0. So the coordinate will be x equals negative 2, and then we take this negative 2 and chuck it into the equation to get our y value. So we can chuck it in here, for instance. So that's negative 2 squared is 4, minus 4 times negative 8, which ends up being positive. Positive 8, 4, 12, 16. So I think it's 16. So yeah, it will be 16. Okay, perfect. Now let's move on. So the functions question here, we've got a function that's defined by 2x plus k, where we've got the domain is x is a set of as a member of the set of real numbers. K is constant, and we know that k equals 3, and we've got to solve this equation here. So we're basically putting in 2x plus 3 into the function again, and that should be equal to 25. So then I'm going to go, well, that's 2. My 2x plus 3 becomes my x. And then I go plus 3 again, equals 25. So I should get 4x plus 6 plus 3 equals 25. Take that across, so I get 4x plus 9. So subtract 9 from there, which will give us 16. So x ought to be equal to 4. Then we're done. The function g is defined by this value here, x squared minus 6x plus 8. The domain is x is a member of the set of real numbers. Find a set of values for which fx equals gx has no real solution. So we go to gx. So we've got 2x plus k equals x squared minus 6x plus 8. Bring everything across to the right hand side. So we've got x squared minus 8x plus 8 minus k. Now, for there to be no real solutions, we know that b squared minus 4ac is less than 0. So we're just chucking our values. Minus 8 all squared minus 4 times 1, because there's just a coefficient of 1 there, times the c value, which is 8 minus k, and this should be less than 0. So we get 64 minus 32 plus 4k is less than 0. So we get 32 plus 4k is less than 0. So 4k is less than negative 32. So k is less than negative 8. And that would be our answer to that one. Okay, let's move on to the next section, next page. It's a coordinate geometry question. Diagram shows 3 points, 2, 14, 14, 6, 7, 2. The point x lies on AB, and CX is perpendicular to line AB. Find by calculation the coordinates of B. Okay, so first of all, I'm going to find gradient AB. So for this, it's 14 minus 6 over 2 minus 14. And this gives me 8 over negative 12, which is negative 2/3. Therefore, gradient CX equals 3 over 2. And I'm going to find the equation of AB. So that's going to be y minus, I'm going to use these coordinates here, y minus 14 equals negative 2/3 x minus 2, and I'm going to rearrange that. Now when I do that, I get negative 2/3 x plus 4/3 plus 14, and that gives me plus 46 over 3 when I do that. Now I'm going to find equation CX, because then once I've got that, I can make them equal to each other and I'll find the coordinates for x. So equation CX is going to be y minus, I'm using these coordinates here, y minus 2 equals 3 over 2, which is the perpendicular gradient we just worked out previously, into x minus 7, and I should get y equals 3 over 2 x minus 21 over 2 plus 2, and that will give me negative 17 over 2 all up. Okay, now I'm just going to make those two equal to each other. So I go negative 2/3 x plus 46 over 3 equals 3 over 2 x minus 17 over 2. And I bring everything to one side. So I get 13 over 6x equals, now what can I do? So I'm going to add that 17. So I get 143 over 6. And then I get x equals 11. And therefore I can plug in my y value to either of the equations, and when I do that, I'm getting 8. So the coordinates are 11, 8. Okie dokie, the ratio of AX, XB. Well, I guess there's a couple of ways of doing this. You can find the length of each one. So AX is the square root of 9 squared plus negative 6 squared. So how do I get from A to X? Well, I go across 9, right, from 2 to 11, and then I go down from 14 to 8, which is negative 6. So when I square those, add them, and then square it, I get square root 117. And if I do the same with bx and find the length there, I'm going from x11 to b14 for our x values, so 11 to 14, which is 3. I'm going to square that. Then look at my y changes. I've gone from 8 to 6, which is going down negative 2. I square that, and altogether there I've got 9 and 4, which is 13, so square root 13. And so the ratio is therefore 117 to 13, which simplifies down to 9 to 1. Okay, so we're on to a circular measure question now. We've got a circle with centre O, radius is 3. The radii OP and OQ are extended to S and R respectively. So the ORS is a sector of a circle with centre O, given that PS is 6 and that the area of the shaded region is equal to the area of the circle C. Show that POQ equals 1/4 pi radians. Now, area of a circle is pi times r squared. So the area of the circle is 9 pi, because pi times 3 squared. And that apparently is equal to the area of the shaded region. Now, the shaded region is going to be equal to half r squared theta. So half times, now I'm going to use this radius here, which is 9. 9 squared times theta minus, and then I've got to cut this little bit out here, which is half 3 squared theta. And so I get 9 pi equals 81 over 2 theta minus 9 over 2 theta. And I guess at this point I'm going to get 9 pi equals 72 over 2 theta. And so theta equals 18 over 72, which is pi, which is pi over 4. So we've got that. Now we've got to find the perimeter of the shaded region. So you can see that we've got 6 plus 6. Okay. So 2 lots of 6. Then we've got this bit here, which is r theta. So it's r, which is 3 times pi over 4. And then we've got this bit here, which is again r theta, but this time r is 9. And then when we add all of this up, what do we get? So we get 12 plus 3 pi over 4 plus 9 pi over 4 equals 12 plus, now that's 12 pi over 4, which is 3 pi. And that's it. Okay, now we've got a trigonometry question. We have to express the equation, blah, 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 is a quadratic equation in cosine squared x. So my first line is going to write 2 cosine squared x equals sine squared x over cosine squared x. So we get 2 cosine to the power of 4x equals sine squared x. Now I'm going to change my sine x into 1 minus cosine squared x. And then I'm going to bring everything across to one side. So I get 2 cosine to the power of 4x plus cosine squared x minus 1 equals to 0. And then at this point, then I've got to solve it. So this is part B. I'm going to factorize. So I go 2 cosine squared x minus 1 into cosine squared x plus 1 equals 0. So cosine squared x equals negative 1, and there's no real solutions for that. And the other option is cosine squared x equals 1/2. And so cosine x equals plus or minus square root 1/2. And therefore x is equal to the inverse cosine of plus or minus the square root of 1/2. Now, when we do the now we want to be in radians here, so make sure your calculator is set to radians. It's cosine square root 1/2. So if we do the positive 1/2, we get 1 over a pi over 4. And now here's our cosine. So this is pi. We're only going up to pi. This is pi over 2. So we get 1 here at pi over 4. Same. And the other one is a negative. Now, this is 3 pi over 4. And it'll be in here. So those are the only values that we'll have in solutions in the range. Okay. And then next one is a series question. The first two series of geometric progression are 64 and 48. So A equals 64, AR equals 48, and therefore R is equal to 48 over 64, which is 3/4. So that's a little bit of information there. First three terms of a geometric progression are also the first, 9th, and nth term, respectively, of an arithmetic progression. Find the value of n. Okay, so what we can do now, I guess, the third term of the geometric progression is therefore AR squared. In this case, we're going to go 64 times 3 over 4, and we're going to square that, and that gives us 36 as our next term. So term 1, so A for our arithmetic. So arithmetic, the first term, so is A is also 64 in this, and then the second term, the 9th term. So 64 plus 9 minus 1 d equals 48. And so 64 plus 8d equals 48. And so 8d is equal to 48 minus 64, which is negative 16. So d is equal to negative 2. And now the last bit is the nth term. So we're doing this bit now respectively. So the nth term is 36. So 64 plus n minus 1 times d, which we've found to be negative 2, is equal to 36, which is our nth term. We've got to find out what n is. So we get 64 minus 2n plus 2 equals to 36. And we get, I'm going to say 66, take away 36, so 30 equals 2n. So I think n is therefore 15 in this case. All right. Let's move on to the last page of work for the day. The first three terms in the expansion, blah, are, so we've got to find them. Okay, so I'm going to go 5, choose 0, times 2 to the power of 5 times ax to the power of 0, plus 5, choose 1 into 2 to the power of 4 into ax, to the power of 1, plus 5, choose 2 into 2 to the power of 3 into ax to the power of 2. Now this will give us 32 is our first term. The next one's going to be 5 times 16, which is 80, so 80 ax, and then the final one, 5 choose 2, what's 5 choose 2? 10 multiplied by 8, so that's also 80 a squared x squared. Now the next bit is, given that the coefficient of x squared in the expansion of blah is 240, we've got to find the possible values. So what we're going to do is we're going to write this 1 plus 2x, and then the bit that we've expanded in the previous question, because they've given us what we need to work out the possible ways we can make a x squared term. So if you think about it, how do we make an x squared term? Well, obviously we can do this one here, but there's another way that we can do it too, and that is this way here. Okay, so let's do that. So we're going to get 160 ax, that's the top one, ax squared, and then the bottom pink arrow will give us plus 80 a squared x. Now the coefficient is 240, so we can now find a. So 160a plus 80a squared equals 240. Now I'm probably just going to divide everything out by, I think, 40. So I'll get 6 on this side, I'll get 2a squared on this side, and I'll get 4a on this side, and I can divide again. So I'll divide by 2 this time, so I get 2a plus a squared equals 3. Now I'm going to bring everything over to the left-hand side, plus 2a minus 3 equals 0. And so we get a plus 3a minus 1 equals 0. And then the possible values of a equals -3 or +1. And those are our values. And the final question we have today is a differentiation question. We've got a curve and a tangent to the curve, and we've got to find the equation of the tangent. So we probably want to differentiate first. So dy dx equals, now here's our y. Now hopefully you've remembered how to do the old chain rule here. So we take this value here and we multiply it by the coefficient, so that's -6, and then we're going to drop down the power of the bracket. So it'll now become squared. And that's it. Now you could do it slowly. Remember, the other way of doing it is u equals that middle bit, 3 minus 2x, and so du dx is equal to -2. And then you can go y equals u to the power of 3, and dy du is therefore equal to 3u squared. And then, my brother's playing Civilization at the bottom of the screen there, if you can see it. Okay, so then we can go dy dx equals, we times this one by this one, so we get, oh sorry, not by that one, by this one by this one, to get dy dx, so we get -6 u squared, and u of course is this, and then squared there. So it's exactly what we got using the quick method that I've shown you. So that's the gradient. Now, at x equals 1/2, what do we get? Dy dx equals, now you chuck in a half here, so 2 times a half is 1, 3 take away 1 is 2, so we get 2 squared, which is 4. 4 times -6 is -24 is our gradient. Then we use y minus y1 equals m into x minus x1. We take our coordinate, which is where the tangent is, so it's y minus 8 equals -24 into x minus, and we use our x coordinate here, which is 1/2. And we get y minus 8 equals -24x plus 12. And so we get y equals -24x, and then I add that 8, so I get plus 20, and that will be my final answer. Well, I hope this has been really helpful to you guys. Let me know if there are any questions or if I've made any silly mistakes that I need to correct. And God bless.